Okay, good evening and welcome back. So so we're going to do chapter 16 tonight in your textbook. And so let's see, just a few reminders that the chapter 7 and chapter 8 homework, those should be graded, or those are graded. And so you should be able to see your grades for those. And I put my solutions for those two assignments. And then this assignment from last week, that's due today. So make sure if you haven't turned that in, that you do that by the end of today. And I'll get those grades up at some point next weekend. And is everyone okay getting in the chapter 9 homework? Any problems with the chapter 9 homework? Okay, so let me know if there's any issues with that, but it seems like we're okay with the homeworks up to this point. And I think I put like your total homework grade up as well on Blackboard. So you should see something like okay, so I think you should see something like that, homework with all, and that's just basically just an average of all the homeworks that we've done. And so that's just the total percent you've done of your homework or gotten credit for. And so you should be able to see that. Most of you have done most of the homework assignments and done well in those. And so if you see that and have any questions on your homework grade, then let me know. So again, chapter 7, chapter 8 homework's graded, and my solutions are posted. The chapter 9 homework is due today or tonight, and yeah. And then today we're going to jump to chapter 16 because that's what I want. That's the last topic I want to cover before the next midterm. Okay, so chapter 16 today, we're gonna revisit the production possibilities curve model from chapter 1 and use that to illustrate gains from trade. Okay, so if we're good to go, let's jump right into chapter 16. Okay, so we can open up the study guide and the examples for chapter 16. All right, and then we can open up the PowerPoint for chapter 16. All right, so this chapter, there's basically like one big type of problem that I want you guys to learn, and we're going to present that and go through kind of two big examples. So most of today's class will be going through two big examples, and then you'll have another one of those questions on your homework, and another one in the midterm. So you're going to have to know how to do this type of question. It's somewhat a long question, but it's a kind of fun way of illustrating how you can show gains from trade from one or more countries or economies. Okay, so there's one big type of problem that I want to, that's the main takeaway from this chapter. We're going to I'll kind of run through a few slides, but the best way to learn this material is to kind of work through an example. So that's what we're going to do most of today. And so we'll go slow. You got to, if there's any questions along the way, like how to do the different steps of this problem, then please let me know, because the basically all we're doing, the main itinerary of today is doing the same problem. It's a big problem. We're going to do it twice, and I think doing that you'll get an idea of how to solve it. Okay, so let's run through the few key concepts and slides, but the bulk of today's lecture will be doing this big example. Okay, so we're going to illustrate how an economy or countries can get gains from trade by looking at the production possibilities curve examples for two different countries or economies. All right, so the first key concept is to illustrate comparative advantage using the production possibilities curve analysis. And we're also going to illustrate how you can get gains from trade when one or more countries, or I guess when both countries specialize. So basically, we're going to define comparative advantage. The country that has a comparative advantage in producing one good will specialize in that. And then by default, the country that has the comparative advantage in the other production good will specialize in that, and they'll both produce only those things. They'll both trade with each other, and they'll both be better off by doing this strategy. Okay, so this is the goal here, is to illustrate comparative advantage, then to illustrate gains from trade. All right, so let's look at the slides real quick, 7 to 12. But again, the best way to learn this material is to work through an example. So slide 7. Okay, so we're trying to illustrate comparative advantage by using the production possibilities curve analysis. So the assumptions here, we have two nations, okay, or two economies, two countries, whatever you want to, just two separate economies. Okay, they have the same size labor force. They each have constant costs in each country, but different costs between the countries. That's the key thing, is it's more costly or less costly comparatively. Okay, and basically the opportunity cost ratio is going to be the slope of the curve, and we're going to look at linear examples to make it a lot easier. So this example in the PowerPoint takes two countries. I think it's the U.S. and Mexico, and the two goods are avocados and soybeans. Okay, and so we're gonna just show kind of the concept here, how you can have a specialization in trade, and basically the idea is this here, is you want to produce as a country the good with the lowest domestic opportunity cost. So whoever has the lowest opportunity cost, whoever gives up the least, that country will produce that good. All right, so we'll see here that the opportunity cost of soybeans, a ton of soybeans, is 3 tons of avocados for the US and 4 tons of avocados for Mexico. So basically, whoever gives up less should produce it. And because the US only gives up 3 tons, right, they have a comparative advantage. Okay, so we probably recall something like this where we had different production alternatives in chapter 1 for like the production possibilities curve analysis, right, where you just plot the points and illustrate the opportunity costs. So now we're going to take that concept, go back to it, look at two countries, and then do the analysis with specialization, and then with trade. So we have two countries producing the same goods, but they have different cost ratios. Okay, so the idea is to see what each country gives up for producing one type of good, and the country that gives up the least basically has a comparative advantage, and they're going to specialize and produce that. So, see, for soybeans, um, let's see. Okay, so soybeans, Mexico gives up 4 tons of avocados to get a ton of soybeans, and the U.S. gives up 3 tons of avocados to get a ton of soybeans. Okay, so because the U.S. gives up less avocados, they have a comparative advantage because they only give up 3 compared to Mexico's 4. All right, so the idea here is that they have a comparative advantage, the U.S. in producing soybeans. They're going to specialize in that and produce only soybeans. Now, it's going to work out that the other good is going to be produced by the other country, but just to go through the example. So Mexico, when we're looking at avocado production, Mexico gives up a 1/4 ton of soybeans to get a ton of avocados, and the U.S. gives up a 1/3 ton. So the idea here again is that whoever gives up less, right, has a comparative advantage, and they should produce that. So so Mexico gives up a little bit less, and they're going to specialize in avocado production. Okay, so once we go through the examples and figure out this, who should specialize in what, then we need to determine what the terms of the trade are, like what trade would make both countries better off. Okay, and that depends. So basically, both countries have to get better than their opportunity cost, and if that's the case, then they'll make a trade. Okay, so here, a trade that will make them both better off is to trade 1 ton of soybeans for 3.5 tons of avocados, and that's going to give both countries better off than their original opportunity costs. Okay, so they'll specialize, they'll trade, and they'll both be better off after that deal. Okay, so in the examples we're going to go through, we're going to kind of make this chart, and we'll start from scratch. So this is you'll get the idea once you do it 2 or 3 times. Okay, so we're going to determine what the country's outputs are before specialization in trade. Column 1, then column 2, we'll decide which country should specialize in what and show those outputs. We'll show what they're going to trade. Okay, that'll be determined by the question, and then we'll see what their outputs are after they specialize in the trade. And we're always going to find that. I mean, sometimes one of the countries or economies might not gain in both goods, but they're all going to gain at least something. So both countries somehow or some way after the specialization trade will be better off after the trade, and that's what we're trying to show here. So these are the key ideas, and again, there's a lot of information. It's hard to see what's going on in the PowerPoint, and that's exactly why we're going to work through some big examples right now. Okay, so the rest of the material in chapter 16, you're not going to be tested on it. The only thing you're going to be tested on is this big problem of gains from trade using the production possibilities curve analysis, and that's exactly what we're going to do for the rest of class. Okay, so those are the key concepts. All right, and there's a nice little video if you want to look at that when you have some time, 10 minutes or so on gains from trade. So that'll explain a little more of the logic behind it. So that's a good video. Okay, so there's 2 examples here. And so they're examples. They're examples from your textbook, but I modified them a little bit to have like the same question that we'll go over multiple times. And so I got my solutions here, and I got my Excel file. I think the best way to go through this is for everyone to learn it. I think is just to kind of start from scratch. And so I'll instead of just going through the answers here, let me try to do it like from a blank page. And that way, if you guys can follow along, you'll let me know if you have any questions, and then I think we'll learn it better that way. Okay, so let's get ready to do these big examples, and we'll start with this one. Okay, so example number one: the following hypothetical production possibilities tables are for New Zealand and Spain. All right, let's assume that before specialization in trade, the optimal product mix for New Zealand is alternative B, and for Spain is alternative S. So it's telling you their production possibility options, and it's also telling you where they're currently producing. Okay, so we need the initial spot to show how they're going to be better off after the trade. Okay? So here's the table, and these are the different production alternatives for apples and plums for both countries. So there's New Zealand, points A, B, C, and D. They can produce those options. And there is Spain. They both have the same goods, but they have different cost ratios. See that? Okay. So one of those tables should be very familiar with doing the production possibilities curve from chapter one, if you recall that. And now we're just adding a second country and extending the analysis a little bit further. But we're starting with the same idea. All right. So part A is always going to be draw the production possibilities curve for country A and country B. In this case, it's for New Zealand and Spain. Okay, including including the optimal product mix before specialization in trade. Okay, so let me just, I'm going to pull up a blank Excel file, and I'll do most of this in Excel. And again, like the rest of the problems, you can do your homework and your exercises in Excel, or if it's easier for you, you can just draw it on some graphing paper and do your homework that way. So whatever is the best way for you to do this, it's fine with me. I'm going to do it in Excel because it's easier for me to illustrate it. So let's start with just a blank Excel workbook, and we'll start doing the problem. So the first thing we're going to do is just replicate the tables and draw the curves. Okay, so the first thing you want to do is just put in the information from the tables, okay, and then we'll start with that. So we were given um, the production alternatives for both countries. So let's just type those in. If you're doing that in Excel, you can do it like this, and if you're doing it just on a piece of paper, I think it's a good idea to kind of reproduce the tables just to kind of see what the different points are. So we have Spain and we have New Zealand. Okay, so all right, so sorry, New Zealand has points alternatives A, B, C, and D. All right, and the current alternatives are 0, 15. Okay, so that was given. That I'm just reproducing the table from the problem. Okay, so that's for New Zealand. Then we also have I'm going to do another table for Spain. Okay, and they have alternatives R, S, T, and U. All right, I'm just going to type in their initial production options. All right, so there we go. So those are given, right? And you can see that the um, opportunity costs or the graphs are going to be linear, right? So you can kind of go through and see like this changes by 20, this changes by 5, this changes by 20, and so basically for Spain it's a 1 for 1, and for New Zealand it's a little bit different. Okay, so all you have to do here, if you wanted to draw the graph in Excel, you would just select the alternative points for all the numbers and just make a line graph or a scatter plot, whatever. Okay, so if I do insert and well, they don't have the one I want recommended. If I do insert in all charts, well, we're doing this one. Okay, so uh, the best one is this one here, the line chart. So let's go ahead and do that. Here it is. Oh, that's huge. All right, so this is the graph for New Zealand, or sorry, yeah, for New Zealand, right? Yes. Okay, and if you want, you can label the axes so you know what is what. All right, so if you click on, you've probably done this before, but if you click on the chart elements or the plus sign, you can add the axes titles. And axes titles and show which good is on which axes. Okay, so this one going from 0 to 20 is the plums. And this one going in increments of 20 is apples. Okay, and I like to show it so it's the same. Basically, the chart is the same as the labels. So this one's right 0, 20, 40, 60. This one goes 0, 5, 10, 15. And we can just, it's fine. We can leave it like that. All right, so there's the graph, and it said to show the initial point, the initial production point. So part A said draw the production possibilities curve for both countries. We've done one of them. And then including the optimal product mix before specialization and trade. So it said in the intro that New Zealand starts at alternative B, right? So they're starting here, okay? And if you want, you can make a little reference on your chart. So 20 apples and 20 apples and 10 plums would be right there. And if you wanted to, you could add a data callout to show the points like this. There we go. So New Zealand starting there. Let me do another one for Spain, and then we're almost done with part A. Okay, I'm gonna make Spain. I made New Zealand blue. I'm gonna make Spain green just to be consistent. All right, we can add labels, then we can show the initial point for Spain, and then we're done with part A. All right, so again, this one's gonna be apples. And that's plums. And let me just format the axes a little bit to be like this one. All right, so I wanted to go in increments of 20, not 10. All right, and maybe I'll do this. I'll do the same for this one, just to show consistency. So this one on the table went from 0. 0 to 15 in increments of 5. Okay, so I can just have it exactly like the table. All right, so there we go. We can see all these points up here for New Zealand. We can see all the points here for Spain. Last thing is just to show the initial production point for Spain, which was alternative S, which is this one. All right, so 20 apples and 40 plums. All right, so there we go. The first part is just to make those graphs. Everyone okay so far? Just all we did there is either put the data in Excel, make a graph, or if you want to do it just on graphing paper, you can do that. So everybody following along so far? All right, perfect. So step, not step, part B. Okay, so we did that, and if you were doing your homework in Excel, all you have to do is just copy and paste your tables here, like we did there. All right, part B. All right, this is important. So are comparative cost conditions such that New Zealand and Spain should specialize? And if so, what product should each produce? Okay, so we're trying to determine the opportunity costs of both goods for both countries, then figure out which country has the lowest opportunity cost. They're going to specialize in the one they have the comparative advantage in and produce only that, and that'll be the same for both countries. So first we need to determine the opportunity costs of both goods for both countries. All right. So let's determine the opportunity costs of plums for both countries first here. Okay. So we've done this before in the um, production possibilities curve example, and we also did this is very similar to what we did in the budget line, right? Just determine what you give up to get more of the other good. Okay, but there's no prices. It's just production alternatives. Okay, so let's note what every time New Zealand gains plums, what do they give up? Okay, so just start with the numbers here. So you can see that each time, right, New Zealand, it's constant, so it's easy. You don't have to worry about it changing. So each time they produce 5 more plums, you can see they give up 20 apples, right? So plus 5 plums, they lose 20 apples. Plus 5 plums, they lose 20 apples. All right, so that's the trade-off. Okay, so 5 plums equals minus 20 apples. And then you always want to put it in terms of just one good so you can get the true comparison. So to determine what 1 plum costs, just divide by 5. But divide both sides by 5, and you see that 1 plum is equivalent to 4 apples, minus 4 apples. Okay. All right. So let's do the same analysis for Spain for plums. Okay. So what every time? So we can see you can probably figure out or see that every time it's a 1 for 1 for apples and plums for Spain. But let's just do the full analysis. So each time Spain produces 20 apples, they lose. Each time Spain produces 20 plums, they lose 20 apples, right? Plus 20, minus 20, plus 20, minus 20. So 20 plums is equivalent, or when they produce 20 plums, they lose 20 apples. So 20 plums equals minus 20 apples. All right, and then obviously if you just divide by 20, you can see that 1 plum is producing 1 plum, you lose 1 apple. All right, so plus 1 plum equals minus 1 apple. Okay, so now we have enough information that we can determine for plums which country has a comparative advantage in producing plums and which country should specialize in producing plums. Okay, so can someone determine which country has a comparative advantage in producing plums? News. Well, so you want to see who gives up less. Okay, so this is a good way to do the analysis because the comparative advantage is who gives up less. So every time New Zealand produces a plum, they lose 4 apples. Whereas every time Spain produces a plum, they only give up 1. All right, so they're giving up less. Okay, so whoever gives up less in terms of the other good has the comparative advantage. All right, so okay, so Spain gives up less in terms of apples. They only give up 1, whereas New Zealand they're giving up 4 every time. Okay, so Spain, right? It's kind of a weird concept but you're trying to see who gives up less. And that's valuable because whoever gives up less, they want to produce it because their opportunity cost is much lower, right? Because they're by producing apples, they're only giving up by producing plums, they're only giving up an apple. Whereas if New Zealand decided to produce plums, they'd be giving up a possible 4 apples every time. Okay, so basically we've determined that Spain has a comparative advantage in producing plums, and Spain should specialize in producing only plums. Okay, so we're probably going to get that the other country, New Zealand, has a comparative advantage in producing apples, but let's do the analysis just to confirm. Okay, so let's determine the opportunity cost of um, apples for both countries. All right. So let's do it. Let's do it for apples now. All right, and then determine the specialization in apple production. So every time New Zealand produces an apple, every time New Zealand produces 20 apples, they give up 5 plums, right? Plus 20 minus 5. All right, and if you divide by 20, you get that 1 apple equals 1/4 of a plum. Okay, and we know that for Spain it's 1 for 1, so plus 20 apples equals minus 20 plums. Okay, and then divide by 20, you know that 1 apple is the same as losing a plum. Okay, so you should see that which country gives up less in terms of apple production. So New Zealand only gives up 1/4 of a plum every time they produce an apple, whereas Spain gives up a whole plum. So the point here is that New Zealand is giving up less, which means they have a comparative advantage in producing apples, right? Okay, so um, we've determined the opportunity costs of both nations. We've determined who has a comparative advantage in each, and who should specialize in what good. So this part B is pretty much is very important because this sets up the rest of the problem. So does everyone see how we did this part? How we get the comparative advantage and who should specialize here? All right. Well, it seems like we're following along. But if there's if anything needs further clarification or you have questions, then just stop me or post something in the chat. Okay. So next part. All right. So what is the total gain in both apples and plums that would result from just specialization? So we'll start with the initial outputs that were given, and then we'll go with the specialization only outputs, and there's going to be a gain in both goods, and that's what we have to determine. So let's start doing this. All right. So I'm gonna start making a table that we're going to finish as the problem goes on, but we just need the first couple columns first. So this is the country. And let's make a column called outputs before specialization. All right, so outputs before specialization. Let's call the next column outputs after specialization. All right, so we were given, and we've already made a note that before specialization, Spain was producing point B, which was 20 apples and 10 plums, right? Okay, so Spain is starting with 20 apples and 10 plums. And, sorry, New Zealand. And Spain started with point S, which we know is 20 apples and 40 plums. Okay, so this was just given that we put here. Spain started with 20 apples and 10 plums. New, Ze- New Zealand started with 20 apples and 10 plums. Spain started with 20 apples and 40 plums. All right, now let's do specialization. So one country is going to produce all of one good and none of the other, and then vice versa. So we've already determined that Spain has a comparative advantage in producing plums, and Spain should specialize in producing plums. So that means they're going to produce no apples and all plums. Okay, so if you look at the whoops, did I do this is that? Okay, sorry. New Zealand has a competitive advantage in producing apples, and New Zealand should produce only apples. So New Zealand is going to produce only apples and no plums. All right. So if you look at okay, so if you look at New Zealand's production possibilities curve, um, if they produce only apples, what's the maximum number of apples they can produce? So New Zealand's going to produce only apples. How many total apples can New Zealand produce? All right, that's the question for. All right, do you see that? Okay, so again, the question is if New Zealand only produces apples, what's the total or maximum number of apples they can possibly produce? Okay, well, yeah, exactly, 60, right? So we're producing 0 plums, and that means that the max we can produce is 60 apples. Exactly. So point D is, yeah, so 60 is exactly right. So Spain's going to produce no plums and opt to produce 60 apples. All right, and then Spain's going to do the opposite. They're going to produce only plums and no apples. So if you look at Spain's picture, all right, we know that Spain has a competitive advantage in producing plums, and Spain should specialize in producing only plums. All right, and you can see that if Spain chooses to produce no apples and all plums, they can produce 60. So they're going to do that. They're going to specialize, no producing apples. They're going to produce all the plums they can, which is 60. Okay, now the question was, what's the total gain in both apples and plums just from specialization? Now we'll get a better answer when we do the trade, but let's determine just by specializing what's the total gain in like both goods if you add the two countries together. Okay, so see apples, we after the specialization we have 60 apples, right, from just the New Zealand specializing, so we have 60. Initially we had 20 from New Zealand and 20 from Spain. So that's 20 plus 20, which is 40. Okay, so after specialization, we had 60. Initially, we had 20 plus 20, which is 40. So the gain or the difference is 20 apples. All right, so let me do plums, and let's make sure that we understand what's going on here. So plums, there's only one country producing the plums, Spain. They produce 60. Uh, the initial total for both countries was 10 for New Zealand plus 40 for Spain. So 10 plus 10 is 50. All right, so the gain or the difference from specialization, all right, in total plum production is 10. Okay, so do we see questions on that part? Do we see how we got the total gain in just specialization for both goods? Okay, great. So next step or next part D is what are the limits of the terms of trade? Remember, this is just determining the the minimum and maximum in which both countries have to be within for both countries to be better off after the trade. So what we're showing here is the boundaries of like what the opportunity cost or the cost ratio of both countries before. All right, they both have to beat their cost ratio before trade to be better off. All right, so let's start with um, one country's specialization, and then we'll. All right, so let's start with. Let's see. All right, let's start with Spain because the plums were first. So Spain is going to produce plums. Okay, so if Spain produces plums, that means that their initial they're going to produce plums and they got to get apples into trade. But initially they every time they produced a plum, they were giving up an apple. Okay, so that means if they're going to do this in trade, that if they want to produce plums, they have to get back in the trade better than one apple. If they didn't, they wouldn't do the trade, or they wouldn't do the specialization or the trade. Okay, so we have to show that both countries have to beat their initial opportunity cost with the trade. Otherwise, this wouldn't be worth it. So let's start with the initial, which is one plum equals minus one apple. Okay, so Spain's going to produce plums, and if they're going to trade for apples, then they got to beat their initial opportunity costs. So they got to get better than this. So they got to get better than one plum equals minus one apples in a trade. Otherwise, they're not going to trade, and they can just do it themselves. All right, so let's make the statement for New Zealand in terms of apples, and then make a trade in which both countries are better off. So we determine that New Zealand's going to produce apples, and okay, so they're going to produce apples. They're going to trade for plums. The initial um, trade-off or opportunity cost for apples for New Zealand was one apple equals minus one fourth of a plum. So if they're going to produce and trade, they need to get back in return at least this, and so they need better than a fourth of a plum. They need half a plum or whatever to be better off. If they didn't get that, then it wouldn't be advantageous for them to trade at all. So they need to beat this initial opportunity cost or cost ratio. Okay, so when I say that Spain needs to get more than this, and New Zealand needs to get more than this, all I'm doing is saying they have to beat their initial opportunity cost in a trade. Otherwise, they wouldn't trade, or it wouldn't benefit them. Okay, so let's put this in terms of one good, like one apple equals one, and then one apple equals something else, and then we'll see what the limits are in which they could both be better off for a trade. So for Spain, it's one plum equals minus one apple. Okay. Now let's put the New Zealand opportunity cost in terms of one plum, and then that'll help determine, or that'll exactly determine the range in which they can trade. So if we put this in terms of one plum, basically multiply both sides by four, we'll see that one plum equals four apples. Or like vice versa, one plum equals minus four apples. Okay, so this part's a little tricky, but these are the limits here because we're trying to show the boundaries in which they can both be better off in a trade, which are basically these. Okay, so if you do this, you basically state what Spain specializes in, and say they have to beat their initial cost ratio. Then state what the other country specializes in, and state that they have to beat their initial cost ratio, and then put both those initial cost ratios in terms of one good equals and one good equals, so they're in the same exchange rate basically. So this is the same as one plum equals minus one apple. This is the same as one plum equals minus four apples. So if the trade is anywhere in between this, they're both going to be better off. All right, so like for example, you can have one plum equals minus two apples. All right, one plum equals minus three apples. Both of those are in between the boundaries. But you see the idea here is that if you had one plum equals minus five apples, that's not going to benefit both countries because that violates, or they could do better just by doing their initial cost ratio. So it's got to stay within 4 and 1. So like one plum equals minus five apples, that's no good. Okay, so we see the idea that it's got to be within the limits. So if it goes too low or too high, then one of the countries is gonna lose out, and they're not gonna make the trade. So see, the limits are one apple and four apples, and it's got to be somewhere within those limits. Okay. All right. Questions on this part? Do we see how we're trying to uh, note the limits? All right. Well, the answer to part D is here are the limits. One plum equals minus one apple, and one plum equals minus four apples. So the trade has to be again in between those the upper of four and the lower of one. Okay. So there we go. Okay. Part E. All right. So let's suppose the actual terms of trade are one plum for two apples, which again are you can see you got to confirm that those are within the boundaries, which they are. So both countries are going to benefit, and so that's the exchange rate. But they're going to trade 12 plums are going to be exchanged for 24 apples. So at the 1-to-2 ratio, they're going to trade 12 to 24, which is 1-to-2. And let's determine the gains from specialization and trade for both countries. Okay? So let's complete the chart with the specialization and with the trade. All right, so I'm going to continue with this chart. So we had outputs before specialization, we had outputs after specialization, and now let's do amounts traded. Okay, and then we'll do outputs available after trade. And then finally, the gains from specialization and trade, which is what we're going for here. So the final column in the F column is the gains from specialization and trade. Okay. Okay, so here are the amounts traded. Let's just put in the actual trade. So the trade, right, from the question was 12 plums are exchanged for 24 apples. All right, so whoever produces the apples is going to trade that many for that many plums and vice versa. So if New Zealand has the apples. They're trading the apples for plums. So they're trading 12 plums for 24 apples. All right. So here's the trade that was given, right? 24 apples for 12 plums. Now they have the apples, so they're losing the 24 apples and they're gaining the 12 plums. And the opposite will be true for Spain. All right, so just see that we're just putting the trade in here, 24 apples for 12 plums, and just pay attention to which country gets the apples and which country gets the plums. So New Zealand had the apples, which means they're trading away the 24 apples, getting the 12 plums. Spain had the plums, which means they're trading away the 12 plums and gaining 24 apples. Okay, so this is just the trade. Now let's look at what's left over for both goods for both countries after the specialization in trade. So let's see. So basically, 60 minus 24 is 36. All right, and then 0 plus 12 is 12 plums. All right, so all I did here was 60 minus 12. Okay, so 60 minus 12 is 36 apples, and 0 plus 12 is 12 plums. All right, let's do the same for Spain. They had 0 apples, they gained 24, so 0 plus 24 is 24 apples. And 60 minus 12 plums is 48 plums. Yeah. Okay, then finally, what is the total gain from specialization in trade compared to the original output before specialization? So how is this better than this for both goods for both countries? So New Zealand started with 20 plums. New Zealand started with 20 apples. They now have 36 apples, so they gained 16. Let's do it. All right, and then they started with 10 plums. Now, after the specialization in trade, they have 12, so they gained 2 plums. All right, now let's do the same for Spain. So they started with 20 over here, and after the specialization in trade, they have 24, so that's a plus 4. So they gained 4 apples. All right, and finally, they started with 40 plums. Now they have 48, so that's a plus 8. So they gained 8 plums compared to the 40, and now 48, that's a plus 8. Okay, so this here is the gains from specialization in trade for both countries for both goods. Now there was a lot of accounting going on there. So if you stick with the logic in the columns, like start with what they had initially, what they specialize in, what the trade is, what they have after the trade, and then finally you have to determine what they gained compared to the initial. And you're going to see that each country gains at least something for both. Sometimes they gain both. Right here, they both were better off for both goods, but you're never going to find a case where one country is worse off. Okay. So, questions on getting to this here? Okay. So the final part of this type of question is part E. No, that was part E. Yep, part F. Okay, so the next part is to draw the new graph the new graph with specialization and trade. So you can either, if you're doing this on graphing paper, you can just show like the better line on the same graph, or if you're doing it in Excel, you can just draw a new um, production possibilities curve with specialization and trade, like I did here. So let me show you how to do that. So we're going to show the comparison to the original production possibilities curve that they can, all the points they can possibly get with specialization and trade. Okay, so back to the spreadsheet. All right, so let's make a new um, table with the options they can get with specialization and trade. So we move these graphs over. Okay, so I usually call the new one like the original points, but I'll just add a prime. So like A prime, B prime, C prime. Okay, so what you're trying to show in the curve, the production possibilities curve, possibilities with trade, is all the points they could possibly get given the trade and given uh, the trade they agreed upon. So what you want to do is start with the initial. So when the country that specializes in one good, they can't get any more of that because they're the only country producing it. So New Zealand is specializing in apples. So just leave their, so they basically they can't get any more apples because they're the only ones producing it. So the easiest thing to do, I think, is start with the initial, um, stick with the good they're specializing in and just leave those points the same. Okay, so leave the Apple points as they are for New Zealand. Okay, so New Zealand's going to specialize in apples, so that means that these are still the optimal points for apples, because they can't gain any more apples initially, right, without trading. But the trade now is a 2-to-1 in which they can get, so it's 1 plum for 2 apples. So that means they can trade any of these 2 apples for 1 plum, right? So what you need to note in the new curve with the trade is, let's see how we can. Um, any of these 2 apples can be traded for 1 plum. Okay, so this point would show that we traded all the apples for all the plums we can get. All right, so if we trade 60 apples, all for plums at 2 apples for 1 plum, that means that we can get, let me, well, so if I write a formula, it might be a little bit easier. So let's see, we can trade equals well, I know we can get back 30 plums because that's the trade, where you traded all the 60 for plums, and because each 2 apples is worth 1 plum, that means you traded all the apples for plums, and you got back 30. So where am I supposed to write this? So I want to give. We have 60 plums. We're trading them for at 2-to-1 for 30. Okay, there we go. So sorry, I'm just trying to write a formula. So each basically because you get 2 apples for 1 plum or 1 plum for 2 apples, that means that each plum or each apple is worth half a plum, right? If you just flip it, so that means you get half of what you have of what you traded away for the apples. So if we kept 0 apples, that means we traded 60 apples at half. We can get a half a plum in return, which means that we get 30. Okay, so if I apply this formula like this, yeah, that's right. Okay. Okay, so what I'm saying, what I'm trying to illustrate is that um, the point up there for the apples is what we kept. So that means we must have traded away the rest. So if we kept 20, that means we traded away 60 minus 20, which is 40. And we can get back a half an apple for, or half a plum for an apple, which means we get back 20. Okay. And yeah, and the same here. So I think that's what I wanted to show. All right, so this the formula is correct, but so here New Zealand can produce apples. So at this point, they produced all 60 apples and kept them all. They didn't trade any. Here, they kept 40 and traded 20. At each one is a half a plum, so that gives them 10. Here, they traded away 40 and 40 apples at the 1/2 ratio gives them 20 plums. Yeah, and here they traded all of them, and 60 apples gives you 30 plums. Okay. All right, so hopefully that made some sense. And let's do the same for Spain, and then let's graph these. Okay, so Spain is going to specialize in plums. Okay, so leave this the same. And the apples part is going to be gained for a trade if possible. So let's do the same kind of formula, but now these are traded for, so one plum gives us back two apples, right? So here it was, this is traded for half a plum, and here it's traded for one is two apples. So that's the trade. So the formula would be here, we kept all the plums. All right, so here the trade is 2-1. Yeah. So we kept all the plums, but what's left is zeros. But we could have traded them for apples. And if I apply this formula over like this, okay. So here, um, we traded away 20 apples, and each of those one. So we traded away 20 plums. Okay. So we kept 40. We traded 20. Each of those plums gives us two apples. So 20 times 2 is 40. All right. And this one, yeah. Here we traded away. We kept 20 plums for Spain. They traded the other 40, and 40 gives us the 2-1. 2 times 40 is 80. And here they traded away all the plums at 2-1, so that gives us 60 times 2, which is 120. Right. Okay. So sorry if that was a little confusing, but what you want to do in the new table that shows the gains from trade is just leaving the initial, like leaving the goods they specialize in as the same from before, and then determine what they can get in a trade for the rest of the ones they trade at the remainder. So here they're trading they're trading all the apples for plums. Here they're trading 40 apples. Here they're trading 20, and here they're trading 0. Okay, and the formula basically says the exchange rate, which is a half. All right, one plum equals half an apple, and then what they decided to trade away, which is 60, minus what they currently have left. And in this one, Spain was specializing in plums, so this line should be the same as this one, and then the formula or the calculation should show uh, what they could have gotten in a trade, right? If they traded away the remainder. So here, they kept all the plums, so they get no apples. Here, they kept 40. They traded the other 20, and 20 times 2 is 40. Here they kept 20, and they traded the other 40. 40 times 2 is 80. And here they traded all of them, and 60 times 2 is 120. All right. So you don't have to do the formula or the Excel version, but I think it makes it a little easier if you can do the formula and confirm that it makes sense. And the very last part is just graph the new curves. Okay, so let's just graph this one for New Zealand. Okay, so this is New Zealand with specialization in trade. All right, and if you do a little formatting and add the axes, you can see the total gain they can get if they trade the things they were specializing in. So each time, we're just showing basically the exchange rate. So the initial specialization and what they could possibly get at any trade given the trade they agreed upon. Okay, and then if you format it to show just like the table that you made over here. All right, so plums go from 0 to 30 in increments of 10. And then the specialization good should be the same axes because they can't uh, initially gain any more without the trade. And then let's do the same for Spain. Okay, so this is Spain with specialization in trade. All right, and we see the plums go from 0 to 60 in increments of 20. Okay, so that's good. And then the apples go from 0 to 120 in increments of 40. So wait, so plums 0 to 60 in increments of 20. Okay, and then apples, I think, are right, 0 to 120 in increments of 40, right? Yeah. Okay, so in both, so here's what we were trying to show is the better off they can get with the trade in the specialization. So here's the initial New Zealand, right? They can do 0 to 15, 0 to 60, but they're going to specialize in apple production, and they can trade all those apples if they want to at the exchange rate for plums. So they could possibly get any of these points on here. So see how the maximum they could get is 30 as opposed to the initial 15. So they can get up to double the amount of plums by the trade they agreed upon. So any point in this curve, right? So it basically starts at 60 and it goes up like this. See that? So any point except for just producing 60 apples. So any trade they make, they're better off, right? Okay, the same for Spain. If they initially produce, here, this goes from 0 to 60 and this goes from 0 to 60, they're going to specialize in plums, right? So this intercept is the same, but the new line basically goes out like that. And so you can see that any trade for apples, they're going to be better off, okay? So both countries, as long as they make any trade within the agreed upon limits, the new curve shows that that trade is going to make both countries better off. All right, so this was just one example of a better off trade. Okay, but the new graph shows all the points at which they could possibly make a trade, and all those points for both countries, they're better off no matter what, as long as the trade, it goes within the limits. Okay. Okay, so that took a while, but that's the full problem. So there you would put the new graphs with the specialization and trait. All right, so it's somewhat of a long problem, and it took a while to explain it, but hopefully this made some sense. And questions on any of the components we did here. So if you didn't pick up every single thing the first time, that's okay. But it's best to kind of to do the example, and once you do it, you learn the steps. But uh, questions on this at this point? Okay. All right. So I have one other example if you guys want to do it. So it's up. I don't know how long. All right. So are you guys up for another one of those examples, or are we or not? Yeah. Okay. Well, all right. So let me just let's go through the other example, but I won't. I'm okay with either. Okay. All right, let me just run through it, and I won't do it from scratch. I'll kind of show you the steps. All right, so the all the solutions for the one we just did are here, and so let me just show you one more example, but I won't do it all the way from scratch, so it won't take forever. But so here we go. We have it just to show you how you can apply it, and then you have one in your homework. So here's another one. Okay, so we got here production possibility tables for China and the U.S. And assume before specialization in trade, the optimal product mix for China is B, and for the U.S. is U. So here's the production alternatives for apparel and chemicals for China, and here's the production alternatives for the U.S. for apparel and chemicals. Okay, so part A is again just to draw the curve for both. All right, so just plot the points for both countries and draw the curves. There's for China, and there's for the U.S. All right, so I think we got that. Now, part B is to determine the opportunity costs and the conditions at which both countries should specialize. So, first look at apparel. Okay, so every time China produces six apparel, they give up six chemicals. So it's a plus six minus six. So it's a 1-to-1. Oh. Okay, so six apparel equals minus six chemicals, which means that that's if you divide by six, one apparel equals minus one chemicals. All right, so that's for China. Let's look at the U.S. Okay, so each time they produce an apparel, they give up four chemicals. So plus two minus four, plus two minus four, and four chemicals equals minus two apparel. If you divide by four, that means that each time they produce, sorry, plus two apparel equals minus four chemicals. That means if you divide by two, each time they produce an apparel, they give up two chemicals. So you can see that China gives up negative one chemicals, and the US gives up minus two chemicals. So the US gives up more, which means that China is giving up less, and therefore they have the opportunity cost. They have the comparative advantage in producing apparel, and they should specialize in producing only apparel. All right, and then let's do the same for the chemicals. So it's just the flip flop. So if six apparel equals six chemicals, then six chemicals is minus six apparel for China. And it's the same, one chemical equals minus one apparel. Okay, for the US, if 2 apparel equals minus 4 chemicals, that also means that 4 chemicals equals minus 2 apparel. And if you divide by 4, that means that 1 chemicals, you're giving up minus a half apparel. So 1 chemical, China gives up a half apparel. China gives up 1 apparel. 1 chemical, the US gives up a half. The US gives up less, which means they have a comparative advantage in that, producing chemicals, and they should specialize in chemicals. So we determined that China has a comparative advantage in producing apparel, they're going to specialize in that, and the US has a comparative advantage in producing chemicals, and they're going to specialize in that. Okay? All right. So part C is what is the total gain in both apparel and chemicals that would result from such specialization. So we start with the initial points, where China started at B, 24 and 6, and the US started at U, 4 and 12, and then we do the specialization. Okay, so China starts with 2 chemicals and 24 apparel, and the US starts with 12 chemicals and 4 apparel, that's given. Then they specialize. So China specializes in apparel, which means they're going to produce all the apparel they can, which is 30. Okay. And the US is going to specialize in producing chemicals. They're going to produce all the chemicals they can, which are 20. So you see that? Specialization, all apparel 30, no chemicals, and specialization, all chemicals 20 and 0. Now, what's just the total gain in both goods from this specialization? So the total gain in chemicals, we now have 20. Initially, we had 6 plus 12, which is 18. So the gain is 2. All right, and the total gain in apparel is we now have 30. Initially, we had 24 plus 4, which is 28. So the gain is 2. So just by specializing, we gain 2 chemicals and 2 apparel. All right, now part D is what are the limits of the terms of trade. So China is going to specialize in producing apparel, which means they have to beat this one. They have to beat their original opportunity cost, which is 1 apparel equals minus 1 chemical. The US is specializing in chemicals, which means they have to beat 1 chemical equals minus 1 apparel. That's their original. They got to do better than that, or they wouldn't trade. Okay, let's just put both those exchange rates, if you will, in terms of 1 apparel. So this is already in it. 1 apparel equals minus 1 chemicals. And we convert this to 1 apparel equals, multiply both sides by 2, that means 1 apparel equals minus 2 chemicals. All right, so basically the trade has to go in between here. So it has to be 1 apparel for bigger than 1 chemical and 1 apparel for less than 2 chemicals. So 1.5, 1 1.25, something bigger than 1 and something less than 2. All right, so those are the limits. And part E. Suppose the actual terms of trade are 1 unit of apparel for 1.5 units of chemicals. So you can note that that's within the limits, within the boundaries, right? 1.5 is in between 1 and 2. Okay, and so that's the deal. And then the actual trade is 4 units of apparel for 6 units of chemicals. Okay, so that's that's the 4 1 unit for 1 unit of apparel would qualify for 4 units equals 6. Okay, so this is the actual trade deal, and this is the total trade they make. Okay, so 4 units of apparel are exchanged for 6 chemicals. Okay, then let's determine what are the gains from specialization in trade for each nation given this trade. Okay, so we already did this part. And we already did this part. Now let's do the trade. So whoever has the chemicals is going to trade the chemicals and get the apparel. Whoever specializes in apparel is going to trade the apparel and keep the chemicals. Or get the chemicals. Okay, so China specializes in apparel, 30 and zeros, and they're going to trade 4 units of apparel and get back 6 chemicals. So there we go, minus 4 apparel, they gain the 6 chemicals. And the opposite is true for the US. They have the chemicals, which means they're going to trade the 6 chemicals and get back 4 apparel. So they trade, they lose 6 chemicals, and they get the apparel. All right, so here's the trade. All right, then what are the outputs after specialization and trade? So here, 0 plus 6 is 6 chemicals, and 30 minus 4 is 26 apparel, okay? And for this one, 20 minus 6 is 14 chemicals, and 0 plus 4 is 4 apparel. Now, finally, what is the total gain from specialization and trade compared to the original output values? So originally, China had 6 chemicals. After specialization and trade, they still have 6, so they gain nothing. But they started with 24 apparel. They now have 26, so that's a plus 2 in apparel. So they gain something. They're better off at least in one of the goods. The U.S. started with 12, and now they have 14, so that's a plus 2 in chemicals. And they started with 4 apparel, and they still have 4 apparel, so that's a 0. But you can see that neither country is worse off. They both gain something. China gained 2 apparel. The U.S. gained 2 chemicals. Then you have to draw the new graph, which shows all the points they could possibly gain with the trade if they traded the leftover amount of the goods they specialized in. So draw the new production possibilities curve with specialization and trade. Okay, so China would specialize in apparel, which means keep the apparel axes the same. Okay, so this is going to stay the same. So stick with the apparel 0, 6, 12, 24, 30. But they could trade any of those apparel that they don't want to keep for chemicals at one apparel equals 1.5 units of chemicals. So they could trade any unit of apparel for 1.5 chemicals. And that's what this shows here. So here's 30 apparel. Here's keeping them all. If they keep 24 and trade 6, they can get back 6 times 1.5 is 9, right? That's the trade chemicals. If they keep 18 and trade the other, the other 12, yeah, 12 times 1.5 is 18. So this is showing all the possible gains from trade they can get. This is the amount they kept, and this is the amount they traded for at the 1 to 1.5 rate for chemicals. All right, so that's what you're doing here. 30, they kept them all. Here they kept 24 and traded 6. 6 times 1.5 is 9. Here they kept 18 and traded 12. 12 times 1.5 is 18. Here they kept 12 and traded 18. 18 times 1.5 and 20 is 27, and so on, right? So these are all, this is what they kept, and the remainder must have been traded at the 1.5 ratio, which gives them all these options for chemicals. And you'll note that any of these points, B, C prime, D prime, E prime, F prime, they're all better off than the initial production possibilities curve. So if they make any trade at that rate, they're better off. All right. Now the US, remember they're specializing in chemicals, so the chemical axes should be the same. Okay, so this should say 0, 4, 8, 12. Yeah. Okay. And the points here show, so this is what they kept in their specialized good, and then this is what they got back in the trade. But the math is a little tricky here because they're trading at 1.5 for 1, so that means 1 for 2/3 basically. Yeah. Okay, so yeah, the math, the exchange on the homework question, the math comes out a lot easier than this, but this just shows that they get back 1 for 2/3. So one chemical equals 2/3 apparel given the exchange rate. So here they kept 16 of the chemicals and they traded the other 4. 4 times 2/3 is approximately this. All right, so here they got given the current trade for this problem, they got back 13 1/3 and so on. So here they kept all 20. Here they kept 16 and traded 4, and they got back 2 2/3. All right, so the fractions kind of make it more difficult than it is, but it's only because it was 1.5 to 1, and then the reverse is 1 to 2/3. Okay, so what the new curves show are all the initial specialized goods they kept and what they could have gotten back in a trade at the agreed upon rate. All right, so these are all the points that China could possibly get in a trade, and these are all the points that the U.S. could possibly get in a trade. All right, so that's it. We went through that one kind of quick, and I think if you work through the homework problem or kind of work through these examples and kind of get an idea of the recipe and how to solve them, if you do it, if you work through it, you'll understand it more. But hopefully this was helpful to try to explain this type of problem. And questions on this? Do we somewhat understand it? All right. So those are the two examples, and again, all my solutions in my Excel file are on Blackboard. You can look at. So make sure you can solve those ones that we just went through. Now there's a homework question which is basically just another one of these. So I'll show you the homework, but does everyone feel okay or good enough to do the homework? Is it clear what you need to do for this type of problem? All right, so let me show you the homework question, and it's basically what we just did twice, but it's a different example. All right, so here's another problem that this similar type, right? The same process, but different example. So your homework here, you got production alternatives for Cuba and Kentucky, and they're producing different production alternatives of cigars and bourbon. So just graph those. All right, and then determine. So our comparative costing conditions such that they should trade. So determine which good or which country or which economy, whatever, has a comparative advantage in which good and what they should specialize in, right? Then just calculate the total gain in both cigars and bourbon from just the specialization. So just do that, the couple columns in the chart we did. All right, then determine the limits of the terms of trade. So what is a trade that's going to make both countries better off? Remember, you gotta beat the so stick find the good that they're going to specialize in and make the trade such that they both beat their initial um, cost ratios. They got to be better off with the trade. All right, and so this one's a little. I made the trade a little bit easier. It's just 1-for-1. So 1 million cigars are exchanged for 1 million bottles of bourbon, and then I mean, it's 1-for-1, and they trade 50 for 50 million. So just determine the total gains in specialization and trade for both goods. So how many bourbons did Kentucky gain? How many cigars did Kentucky gain? And the same for Cuba. All right, and then part F, show the new curve that they can gain with specialization and trade. So either you can just show this on the initial graph if you're drawing it on graphing paper. Just show like the kinked out or the new line, how it's better than the original, or just draw a new graph. Or if you do it in Excel, you can draw a new Excel chart. All right, so that's the homework question, and I think this is a somewhat difficult type of problem. So hopefully you guys can do this. And so here's your homework question. So you guys can try to work together and see if you can do this one. If there's problems or questions, then just please let me know. Send me an email. If there's if there's major problems, if we can't solve it, then I'm not gonna. I'll help you guys next week. So try to work together, try to do it, and let me know if there's questions that come up. But I think you guys can do it. But yeah, so questions on what I want you to do for this type of problem? Okay, well, so there's the homework question that's due next week, and so this is the last item of new material before the second midterm. So next week, um, I guess next week we're gonna do a review, and then I'm gonna assign you the midterm two, which will be due in 2 weeks, including one of these questions. So just for this week, try to solve this one, and if it's too difficult or if you have problems, then if all you let me know, then we can I'll help you next time. So try to do the homework, but if you can't do it, then I wouldn't worry too much about it. But I think it's a fun question if you try to solve it. So here's the homework. Try to do that by next Wednesday. And if there's any problems, then send me an email and try to work together. But okay, so I think that's it for tonight. So the chapter 9 homework is due today. The chapter 16 homework, this one is due next Wednesday. And then next Wednesday, we'll do a review for the midterm. And I'll assign the midterm at the end of class next Wednesday, and you'll have plenty of time to do that. You'll have a week to do that. Okay, so I think I think that's it for tonight. If there's no more questions, and hopefully you guys can do the homework question. But I'll see you in a week unless you have questions. And have a good rest of the week.
Thank you.
Thank you.
Thank you.
Thank you. Have a good night.
Thanks, Professor. Have a good night.
Thank you, you too.
Thank you, Professor. Have a good night.